Hi, this is K.Banupriya, Assistant Professor, Department of ECE from Sri Shanmugha College of Engineering and Technology. Today, we are going to see the topic on losses in optic fiber cable. So before losses, we have to see what is attenuation. Attenuation means loss of light energy as the light pulse travels from one end of the cable to the other end. It is also called as signal loss or fiber loss. It also decides the number of repeaters required between a transmitter and receiver. Attenuation is directly proportional to the length of the cable. Attenuation is defined as the ratio of optical power output to the optical power input in the fiber of length L. Alpha is equal to 10 log pi by p naught to the base 10. Unit is decibel per kilometer, where pi is input power, P naught is the output power, and alpha is the attenuation constant. There are various losses in the cables due to absorption losses, scattering loss, dispersion loss, and bending loss. Absorption loss. Absorption of light energy due to heating of ion impurities results in dimming of light at the end of the fiber. There are two types of absorption loss. Intrinsic absorption, another one is your extrinsic absorption. Intrinsic absorption. It is caused by the interaction with one or more components of glass. It occurs when photon interacts with an electron in the valence band and excites it to a higher energy level near the UV region. Extrinsic absorption. It is also called impurity absorption. Results from the presence of transition metal ions like iron, chromium, cobalt, copper, and from OH ions. Scattering loss. It occurs due to microscopic variations in the material density, compositional fluctuations, structural inhomogeneities, and manufacturing defects. Linear scattering and nonlinear scattering are the two types of scattering losses. This linear scattering is further classified into Rayleigh scattering losses, Mie scattering losses, waveguide scattering losses. Again, this nonlinear scattering is classified into stimulated Brillouin scattering (SBS), stimulated Raman scattering, that is SRS. We'll see one by one. Linear scattering, Rayleigh scattering losses. These losses are due to microscopic variation in the material of the fiber. Unequal distribution of molecular densities or atomic densities leads to Rayleigh scattering losses. Glass is made up of several acids like SiO2, P2O5, etc. Compositions fluctuations can occur because of these several oxides, which rise to Rayleigh scattering losses. Mie scattering losses. These losses result from the compositional fluctuations and structural inhomogeneities and defects created during fiber fabrications causes the light to scatter outside the fiber. Waveguide scattering losses. It is a result of variation in the core diameter, imperfection of core cladding interface, changing in Ri of either core or cladding. Nonlinear scattering, SBS scattering. Stimulated Brillouin scattering may be regarded as a modulation of light through thermal molecular vibrations within the fiber. Pb is equal to 4.4 into 10 power minus 3 d square lambda square alpha dBV watts, where lambda is equal to operating wavelength in micrometer, d is equal to fiber core diameter in micrometer, v is the source bandwidth in gigahertz. Next, SRS scattering. Stimulated Raman scattering is similar to SBS except that high frequency optical phonon rather than acoustic phonon is generated in scattering processes. PR is equal to 5.9 into 10 power minus 2 d square lambda alpha dB watts, where phonon is a collective excitation in a periodic arrangement of atoms or molecules in solids. Next one, dispersion loss. As an optical signal travels along the fiber, it becomes increasingly distorted. This distortion is a sequence of intermodal and intramodal dispersion. This dispersion loss is classified into intermodal dispersion and intramodal dispersion. Intermodal dispersion. Pulse broadening due to intermodal dispersion results from the propagation delay differences between modes within the multimode fiber. Intramodal dispersion. It is a pulse spreading that occurs within the single mode. It is classified into material dispersion and waveguide dispersion. What is the material dispersion? It is also known as spectral dispersion or chromatic dispersion. Results because of variation due to Ri of core as a function of wavelength, because of which pulse spreading occurs even when different wavelengths follow the same path. Waveguide dispersion. Whenever any optical signal is passed through the optical fiber, practically 80% of optical power is confined to core and rest 20% optical power into cladding. And last one is your bending loss. This loss, which exists when an optical fiber undergoes bending, is called bending loss. There are two types of bending: macroscopic bending, another one is your microscopic bending. First one, macroscopic bending. Bending in which complete fiber undergoes bends which causes certain modes not to be reflected and therefore causes loss to the cladding. Next one, microscopic bending. Either the core or cladding undergoes slight bends at its surface. It causes light to be reflected at angles when there is no further reflection. Thank you.